Okay, so I just would like to have a correction in determining the reaction at the right end of member AB. No? So if you sum up moment at A equal to 0, the reaction at the right is equivalent to 61.74. Okay, and if you add these reactions sa reaction sa B on member AB and reaction sa B on member BC, the sum of this 61.74 and 67.21 is equivalent to 128.95. Dili itong ganina nga 127 point something. So we have now the support reactions of the beam. Okay, so we have this. At A, you have a downward reaction of 1.74 kilonewtons and a moment of clockwise moment 1.958. And at joint B, we have a reaction of 128.95 kilonewtons. And at C, you have 72.79. So we can now draw the shear and moment diagram. Okay, so we have a reaction downward. So downward ang shear equivalent to negative 1.74, and we have minus 60. So minus 61.74, and then we have a reaction of 128.95, so plus, and that will give us 67.21. Then minus the uniformly distributed load of 20 times 6, so that is 120, and 67.25 minus 120, that will give us negative 52.79. Okay, and then we have an upward reaction of 72.79, and that will give us positive 20 and constant shear since there is no load. And then at the end, so we have 20 kilonewtons downward, and that will close our shear diagram. Okay, so our moment diagram, at A, we have a clockwise moment of 1.958, so positive 1.958, and then minus this area, so we have minus 1.522, and then minus this area, so that would be minus 63.26. So as you can see, this moment here coincides with our moment at B, which is 63.26. Okay, and then so by ratio and proportion, we can determine the distance, and that is equal to 3.36, and at the other side is 2.64. Okay, so adding this area to negative 63.26, we got 49.65, minus this area, and we got minus 20, and plus this area, 20 times 1, 20, so that would be equal to 0. Okay, for our elastic curve, okay, we draw the beam, we place the supports, and then note that there is settlement at B. So kani, mo settle po na siya equivalent to 9 mm. Okay, so dili ka mo agi diri ang imong elastic curve. Kaya ani ka mo agi, so it means there is no settlement and the deflection is 0. Okay, so we draw our elastic curve, and we based our elastic curve from the moment diagram. Okay, as you can see here, we have a positive moment, so our curve will be concave up. So maning murag smile siya, musaka dito, and here to here is negative moment, so concave down. So ato lang i-exaggerate. Okay, so ari siya maagi sa ubos kayong settle. And then we have positive moment, so concave up, and then negative moment, concave down. So if you want to determine the displacement at this point, so you know already the procedure. You have area moment, conjugate beam, and unit load method. Okay, so if you want to locate the points of inflection, how are you going to do it? So consider this as X and project it up. Okay, then i-cut nimo nga section. You have your free body diagram. It's either you consider the left section or the right section, and consider that as X. You solve for the shear and the moment at this section, and equate the moment to 0. Okay, aron ma-solve nimo ang x. Okay.